So when you are talking about chemical bonding in biology, you basically want to understand the types of bonds. Now the question is, why bonding? Okay, bonding is just a coming together of atoms, all right, to form a compound. Now why bonding? So the reason as to why atoms bond, there is no other reason but to attain stability. Okay, the reason as to why atoms are getting to bond with others is to attain stability. You are going to see some atoms are going to lose electrons, others are going to gain electrons. The main instance is just to attain stability. Now, some atoms, for them to be stable, they have to have 8 electrons in the outermost shell. This is feeding the octet. Okay, others, for them to be stable, they need to have 2 electrons in the outermost shell. This is the duet. Now, the aim is not to fill up 8 electrons in the outermost shell or 2 electrons. The aim is to attain stability. You are going to talk of atoms such as boron. This one can have 6 electrons in the outermost shell, but it is stable and it doesn't need to have more than that. Only 6, but it is stable. So you don't fill the octet, you don't fill the duet. The aim is to what? Attain stability. That is why atoms get to react. Now we have got different types of bondings, as you already know. So we have got covalent bonds and non-covalent bonds. Okay, starting with covalent bonds. Let's start with covalent bonds. Now, of course, we know that a covalent bond, yes, Casey,
But what is chemical bonding?
chemical bonding is just a coming of atoms together to form a compound.
Okay, thank you.
All right. So we have got different types of bonds, as we are saying. Martha, you have got a question?
No, sir, I didn't get you. Say what's the main reason why we don't do the octet and the duet?
Okay, so we are saying the many instance of chemical bonding is to attain stability. Some atoms are going to be stable even if they don't feel 80 electrons in the outermost shell. So the main instance of atoms bonding is to attain stability. Okay?
Okay, sir, thank you.
Alright. Now, types of bonding, I've said we have got covalent bonds and non-covalent bonds. Yes, now there's a question. Now you can go on. It seems it's a mistake or something. Okay, so let's start with covalent bonds. I think this we already know that covalent bonds. How are covalent bonds? Lilian Imbewe and Naomi. Your hands are up. You've got questions? Yes, Lilian.
Is this a new topic or you're doing a continuation?
It's something new. I will say it's new, but it's atomic structure.
Alright, that's why I'm confused.
Okay. Okay, so what we are saying is that atoms are going to bond to attain stability, right? So we have got different types of bonds, covalent bonds and non-covalent bonds. Now, what are covalent bonds? So covalent bonds are just bonds that result, okay, when non-metals get to react. Non-metals. And also take note that in covalent bonds there is sharing of electrons. Okay, there is sharing of electrons. Now we have got different types of covalent bonds. We have got different types of covalent bonds, and we are going to mention of two. We have got polar covalent bonds. Okay, we have got polar covalent bonds, and we have got non-polar covalent bonds. We have got also non-polar covalent bonds. Now remember, covalent bonds are just bonds which are what? Which are formed by non-metals, which involve sharing of electrons. When you are talking about a polar covalent bond, this one is formed by unequal or uneven distribution of electrons. So when electrons are unevenly, like you are not sharing equally, it's like someone is eating more. Shekaina.
So can you repeat the definition for polar covalent bond?
Okay, so we are saying polar covalent bonds are bonds which result because of an equal or uneven sharing of electrons. So when electrons are not shared equally, then you are going to have a polar covalent bond. Now, a non-polar covalent bond results when electrons are shared equally. Okay, when electrons are shared equally, then the bond that is going to result is going to be what? Non-polar. Now, how do you know that this is going to be uneven, this is going to be even, or this is going to be equal? Okay, equally or evenly. So you can use these two words. Now, when you look at the periodic table, let me draw something like this. So let's say this is a periodic table, right? Okay, we have got an atom here, we've got an atom here. This is a periodic table. So we have got fluorine at somewhere here, fluorine. So we have got what we call electronegativity, electronegative. So electronegative is just the ability of an atom. Electronegativity is the ability of an atom to pull electrons in a shared bond, in a bond. Okay, like to pull electrons to itself. For example, when oxygen is reacting with nitrogen.
Can you repeat that again?
Okay. So when oxygen is reacting with nitrogen, which one is remember when you see a bond like this, a single bond, then you have got two electrons, right? This one brought an electron, this one brought an electron. Now, which one of this is going to, like you bring food together, there's always that one who is fat who is going to be who want to eat more than you, but you've shared you've all brought. Okay? So which one is putting electrons more towards itself? So the one which pulls which pulls electrons more towards itself is the one which is more electronegative. So electronegativity is just the ability of an atom to pull a pair of shared electrons towards itself. Electronegativity is the ability of an atom to pull a pair of shared electrons towards itself. Now, these electrons are not completely leaving. Okay, like even you are sharing. Now, someone is eating a lot. It's not like they are stinging you, but it's just that they are eating more than you. Okay, they are more electronegative. Now, how do you tell electronegative? So, fluorine is the most electronegative atom. Fluorine is the most electronegative atom, meaning that every time you have got a bond of any atom with fluorine and that bond is a covalent bond, it should be between nonmetals, right? Just know that fluorine is going to pull electrons towards itself more. Okay? When you have got hydrogen and fluorine reacting, this is an example of a polar covalent bond. Hydrogen and fluorine reacting. Fluorine is going to pull electrons more towards itself. Why? Because it is more electronegative. It is the most electronegative atom on the periodic table. And so you are going to show like this. You are going to show an arrow like this, and then you put a line like this. Where the arrow is going, this is pointing to the more electronegative atom. And because of this, fluorine is going to have more electrons, and remember electrons are negatively charged, so fluorine is going to have a partial negative charge. Okay, because it has got more electrons around the nucleus. Around the nucleus, it's not like the electrons have been lost from the hydrogen. No, they are just more closer to fluorine than they are to hydrogen. Okay, so we are going to say that fluorine has got a partial negative charge. Alright, at the same time, since hydrogen lacks electrons, hydrogen is going to have a partial positive charge, while fluorine has got a partial negative charge. So when you see something that is positively charged and negatively charged, this is going to be called a dipolar molecule. dipolar molecule. Why? Because it has got two poles. Or you are going to say it is a polar molecule. Why? Because it has got positive and negative, like it's charged. If I just say polar, it means something is charged. It can only be positive or only negative. But if I say dipolar, it means it has got both positive and negative. So this is how polar covalent bonds are formed by an equal sharing of electrons. One is more selfish. So every bond between carbon and I'll mention this one non-polar. So for now, let me say, do we have a question? Any question? Any question? Yes, gift.
Can you please repeat? I never understood what you said.
Okay. So what we are saying is that for you to have a polar covalent bond, you should have an electronegative atom reacting with an atom that is less electronegative. Remember, these are covalent bonds, so these both should be non-metals. Otherwise, if you've got a metal and a non-metal, that becomes another type of bond. Okay, so a polar covalent bond is a bond that results because of an equal sharing of electrons. So you have got the hydrogen, which is like hydrogen is here. It is far away from fluorine. So the more an atom is further away from fluorine, the less electronegative it is. So there is a very big difference in electronegativities between these. So that is why the bond they are going to form is going to be a polar bond. And the one which attracts electrons is going to be partially negative, while the one which doesn't, which loses more, like the one which a bit loses electrons, is going to be partially positive. So this same, before I'm going to talk about water, it is a special thing for me. I'm going to talk about water alone. Water also has got polar covalent bonds. Now when you come to non-polar covalent bonds, they are going to be they are going to have the same electronegativity. Every time you have got the same atom reacting with itself, like oxygen molecule, you are going to see oxygen reacted with an oxygen like this. Like these are the same. They have got the same electronegativity. So there's no one which is able to put electrons more than the other. So they are going to share equally. Because of that, a bond is going to be non-polar. And any bond you see between a carbon and the hydrogen, this is always non-polar. Because carbon is less electronegative. It's in period 4. It's in group 4. And then hydrogen is of course in 1. But the difference in electronegativities between them is less than zero point 0.4. So I'm talking about numbers now. So if you see the difference, like the electronegativity for carbon and the electronegativity for hydrogen, you subtract them, they give you a number less than zero point 0.5. Then that bond is non-polar. If the electronegativity is greater than zero point 0.5, then that bond is going to be polar. If it is less than zero point 0.5, non-polar. If it is greater than, is it 1.5, then that bond is ionic. Now, don't ask me how do you know that it is less than zero point 0.5. Those numbers are going to be given the electronegativities for atoms. Okay. Is this okay? Are we good? Yes, math.
When you said something about electronegativity, if please can you
No,
explain more?
forget about that. Forget about that. Have you understood here?
Yeah, they have understood.
Okay, that's what's important. So apart from a cover, yes, Messi.
Yes, I haven't understood on the how we came about the dipolar thing.
Okay, the dipolar comes because of different poles. Like you've seen that fluorine is more electronegative than hydrogen. So fluorine is going to be pulling, like they've shared electrons, right? But because fluorine likes eating, it's more stronger, in other words. Okay, it is more stronger than hydrogen. In other words, it's a big boy, and then hydrogen is a small boy. So when they're eating, this one will be eating a lot of relish, a big relish, and then you just give a small piece to the hydrogen. So because it has got electrons more closer to its nucleus as compared to the hydrogen, but they've shared, it's going to have partial negative charge. Why? Because electrons are negative. So since it has got more near it, to be partially negative, and the hydrogen, since it has a bit of lost electrons, it has lost negative things, it's going to be partially positive. This more explains if you are near negative people, you are going to be negative like fluorine. But if negative people are going away from you, you are going to remain a bit of positive because your discouragers are away from you. Take it more like that. Is it okay? Messi?
Yes, it's okay, but
Yes.
I don't know. I don't know where the concept of dipolar came in.
Okay, so because now you can see you have got a positive, a negative, and a positive. So polar just refers to positive or negative. So if I say dipolar, it means that you are having two poles. You are having positive and negative. That's the meaning of dipolar. But if you have got like sodium ion is polar. Why? Because it has got a charge. Chlorine ion is also polar. Why? Because it has a charge. But when you have got something that has got both positive and negative, that's what we call dipolar. I don't know if that's okay.
Yes, it's clear now.
Right. So apart from covalent bonds, we also have non-covalent bonds. Non-covalent bonds. Now, what are non-covalent bonds? Non-covalent bonds are bonds which do not involve sharing of electrons, but instead they are going to either involve gaining or losing. There's no sharing, it can be gaining or losing, or just another thing other than sharing, or just a mere attraction. So the types of non-covalent bondings, the first one we're going to talk about is an ionic bond. Now we know that an ionic bond is formed between a metal and a non-metal. Okay, we also know that in this type of bond, metals are the ones which lose electrons, whilst the non-metals are the ones which gain electrons. And apart from that, we also know that the same metals which lose electrons, they are going to become positive. Why? Because they've lost negative things. So they are going to become positive because they've lost electrons which are negative. And then these non-metals which gain electrons, so they are gaining negativity. So they are going to be negatively charged. For example, sodium reacting with chlorine, you are going to form sodium chloride. So the sodium is going to be positive because it has to lose that one electron. And that same electron which is lost by the sodium is going to be gained by the chlorine, and so it becomes negative. And this now gives you the sodium chloride. So sodium is a metal, that's why it becomes positive because it loses an electron. Chlorine is a non-metal because it's a non-metal, and so it gains an electron, forming sodium chloride. So this bond between metal and a non-metal is an ionic bond. Is it okay? Is it okay? Martha, are we clear? You guys, are we together? Am I breaking? Maybe you can't understand what
No,
I'm
I
saying.
didn't get that part. Yes, you're breaking. I didn't get that part.
Okay. Sorry for that. So what I'm saying is that metals are going to lose, and so they're going to become positively charged. Non-metals are going to gain, and so they're going to become negatively charged. So that gives you an ionic bond. Is that okay? Christine, you are still behind? Okay.
It's
I
when it cuts in, so some things are not clear.
yeah, I can see some. Let me just check. Let me just check something here. You might find. Okay. I hope you can now just get me. Okay. Susan, your mic is on. You want to say something?
Mhm. Okay, okay. I couldn't see I couldn't see you. I was just seeing the people that are joining, but now I can see, so it's okay.
All right. Okay. So then,
Yes.
all right. The next type of non-covalent bond. The next type of non-covalent bond. I'm not taking time. We are almost done. The next type of non-covalent bond is a hydrogen bond. So I've seen the network has started misbehaving from now. Yeah. So I hope it will allow me to finish. Yes, please just give Lillian. Yes.
I can't get what you're saying. You're breaking.
Oh, yeah, you are right. So I was just saying my network. I don't know. It has seen 21 hours, so it has started misbehaving. I hope you can. Even the screen you can't see. You can see the screen, right? Okay. So the next type of a non-covalent bond is a hydrogen bond. This is what we need to also talk about. Now, a hydrogen bond is necessarily not a bond, but just an attraction. That's an hydrogen bond. So, for example, you are going to have hydrogen in one molecule. It's attracting either fluorine, nitrogen, or oxygen. Please, this should be from a different molecule. And then this hydrogen is also from a different molecule. So what I'm saying is when hydrogen is attracted to either fluorine or nitrogen or oxygen, not a bond necessarily, but just an attraction, that is going to be called a hydrogen bond. For example, you have got water like this. Okay, this is water. And then you have got another water molecule like that. Okay, so when this oxygen in one water molecule gets attracted to hydrogen in a different water molecule, it is not a, they are not like connecting, it's just an attraction like that. Then this attraction is what we call an hydrogen bond. Now, an hydrogen bond is a weaker bond because it's basically just an attraction. Now, in water, because there are a lot of hydrogen bonds, they are going to be so strong. Like, even if you have got one person who is weak, if they become a lot of them, they are going to be much stronger than you is strong if you are just alone, okay? Because we have got a lot of hydrogen bonds in water. Water, that is why you can't see one water, two waters, three waters, okay? Because of hydrogen bonds. Because of hydrogen bonds. Yes, Martha.
So, sir, for water, it falls under both non-covalent, non-polar covalent,
No,
and
I,
hydrogen bond.
I didn't even mention non-polar covalent. Me, don't lie for me. I'll talk about that. Yes, water's got hydrogen bonds.
No, sir, as in the time that you were talking about. Oh, sorry, not non-polar covalent. The other one, sir. So
Yes,
it's covalent and non-covalent in water.
it is polar and it also has hydrogen bonds. Yes. Okay, so you are going to see like this, and then you can have also another water molecule here. Hope you are able to see. So this water molecule also be attracted to this one like this. Now you don't, just a moment, you are going to see what I've written. Yeah, it has shown. Okay, you are going to see another water molecule being attracted to another water molecule like that, you can see. And then you can also have another water molecule here, like this. And this water molecule, the oxygen will be attracted to this one like that. So we are going to see a lot of hydrogen bonds. So an hydrogen bond is longer than a covalent bond, and it is weaker than a covalent bond. Take note of that. Okay, it is longer and weaker than a covalent bond. So you can't count water because water is always attracted to each other through hydrogen bonds. Every time one water molecule is moving, it will always push another water molecule to move with it. Why? Because this is how you guys should be. Every time you want to pass, make sure that another person should be able to pass. In other words, you are pulling others to pass with you. That's what water does. When one water molecule is to move, it will push with it another water molecule because of the great attraction that it has for other water molecules. So this type of attraction, this is what we call as cohesive forces. So cohesive forces are forces which are between the same molecules. Okay, apart from this, water also is able to attract to other molecules which are not water. So those forces are called adhesive forces. For example, water can stick to your shirt. That is why you are going to get wet, or your shirt gets wet, because of adhesive forces where water sticks to other things other than water. So when you combine cohesion and adhesion, this is what makes water to move up. Like it starts moving from the roots up a plant to the root, to the branches, without even forces pushing it up. It's just because of cohesion and adhesion. So by adhesion, water is going to be attracted to the walls of the plant, and then by cohesion, water is going to be attracting other water molecules. Because of this, cohesion and adhesion will give you what we call capillary action. Okay, capillary action. This will tell you why water is going to be able to move up a tube without any force pushing it. This is very, very important for water. Very, very important for water. Okay, very, very important. All right. So water has got a polar covalent bond and also hydrogen bonds. So water can actually form hydrogen bonds with other molecules like carboxylic acids and alcohols, as long as you have got this. Okay, as long as you have got anything like a fluorine. If you have got another compound like this, HF, you've seen a fluorine can still be attracted to hydrogen. When this happens, you still form a covalent, an hydrogen bond, as long as hydrogen is attracted to either nitrogen, oxygen, or fluorine of a different molecule. Then that is a hydrogen bond, not the same molecule. Okay. Another type of bond which is non-covalent is, there's someone who has a question. Y-
Yes, sir. I'm
yes.
really not clear on the difference between cohesive and adhesive forces.
Okay, so a cohesive force is a force that attracts same molecules, like one water molecule is attracted to another water molecule. Now an adhesive force is a force that attracts different molecules. Like a water molecule can attract an alcohol molecule, or water can stick to a cup, which is silicon dioxide. So different molecules. That's why water can stick to your glass cup when you pour it out because of adhesion, or water can wet your clothes because of adhesion. Is that okay?
Yes, sir.
All right. We also have hydrophobic interaction. Now, hydro means water, phobic means fear. For it comes from phobia. So this means that water fearing. So there are substances which fear water. Every time you get oil, you put it in water. Oil fears water. So because of that, these are the oil molecules are going to come near themselves. Okay, so like oil itself, like a phospholipid is a type of a fat. It has got a part that loves water and a part which hates water. So this is called the head of a lipid. It loves water. So what you are going to see is that when you get to put this in water, these parts which love water, they are going to be near water like that. And then those parts which hate water, okay, I'm going to repeat Shekaina. Those parts which hate water, they are going to be together like that. They are going to actually be inside, okay, like they are hiding. The tails hate water because they are made of carbon and hydrogen. Remember, I said carbon and hydrogen, those bonds are what? Non-polar. So every time you have got something that is non-polar, it can't dissolve in water. Why? Because that thing which is non-polar can't dissolve in something that is polar because water is polar. Okay? So something that is polar can only dissolve in something polar. Something non-polar can dissolve in something non-polar. That is why. Okay, so that is why. Uh, no, I know that someone was calling. That's why the network tripped. Okay, so this explains why when you have uh, a fat is able to dissolve in benzene because benzene is an organic compound. It contains carbons and hydrogens, and then a fat is also containing carbons and hydrogens, so they can dissolve because they're more like are both non-polar. Okay, so this formation you're able to see here, we call them as the micelles. So micelles are formed because nonpolar substances can't dissolve in water. So you are going to see water is going to be outside here. Okay, water is going to be outside there. So that's the mean. Hydrophobic just means water hating. So these parts you can see they are inside here, like those tails. Those which you are able to see they are inside, those they hate water. That's why they are inside like that. Otherwise, this portion which is here loves water. Okay, it loves water. That's why water is going to be here. Water is all outside here. So the part which loves water is going to be interacting with water. So that part which loves water, we call it hydrophilic. Hydrophilic, philic means loving, so water loving. So these heads they love water, but the tails which are inside they hate water. So those which hate water are hydrophobic, they can't react with water. Those which love water hydrophilic, they can interact with water. This is actually what is there in the cell membrane. So the cell membrane, there's a part that loves water and there's a part that hates water. Okay, so the last type of non-covalent bond is called a van der Waals. Van der Waals. I hope that's a spelling. If I'm supposed to put something else, this is also called London dispersion force. LDF, London dispersion force. So for these forces, what we are going to see is that you have got atoms which are not polar. Okay, like take for example, you have got this atom. It has got electrons, right? It has got electrons. It is not polar. And then you bring another atom which has got also electrons. It is also not polar. Now you know that electrons, negative, negative, they repel, right? So what we are going to see is that for these atoms, electrons are going to be pushed. They'll concentrate more on this side. They are going to concentrate on this side. And also for this one, the atoms they also concentrate more on the other side because the negative things are going to be repelling each other. Because of that, this part which is having a lot of electrons will become partially negative. This part that is having less electrons will become partially positive. So the atom starts behaving as if it is polar, while it's not polar at all. Okay, while it's not polar. So a Van der Waals force is just a force that results because of induced dipole. They are induced, they are caused by something. So they've just been caused, induced dipoles. So those are London dispersion forces. So because of this, when you get to react this compound, with another compound that is polar, it will interact with it because it is acting as though it is polar for now. So that is how non-polar atoms are able to interact. Okay, is this okay, friends? Yes, Casey.
So can you repeat on the last, what's this? The last bit.
Okay,
What's the photo attraction?
The London dispersion forces exist when there is uh, like forces are non-polar. Okay, like you've got atoms which are non-polar, but because of induced dipoles, like you induce something starts looking polar because electrons were repelling themselves. Okay, electrons were repelling, and so what you are going to have is electrons are going to concentrate on one side because they were repelling, and that side where they concentrate it becomes partially negative, the side where they are few becomes partially positive. So because of this starts looking as if it's a dipolar molecule. And when you react this dipolar molecule with a polar molecule, they are going to be able to interact. Okay, so this one can also make other substances to be more charged because, or it can attract other substances because it is now charged because it has induced forces. Now, I want you to understand something about water. Water is like this. Water has got two electrons on oxygen which are not reacting with anything. Because of these electrons, these bonds are going to be pushed away from each other. That is why you are going to see water has got a bent shape or a V shape. And the bond angle is 104.9 degrees. Is it 104.9? Okay, so that is going to be the bond angle. So it is going to result, why does it become a bend shape? Because we have got these lone, we call them lone pairs of electrons. So water has got two lone pairs, so this is called a pair. Two electrons is called a pair, this is called a pair. So it has got two lone pairs. Okay, so those electrons are going to be pushing themselves away from each other like that, and so water is going to be what? Is going to be bent shaped. Now remember, oxygen is more closer to fluorine, so oxygen is more electronegative, so it's going to have a partial negative charge here. It is going to be putting more electrons, and then the hydrogen is going to be partial positive. Even the other, this side also is going to be partial negative, and then the hydrogen is going to be partial positive. So this means that oxygen has got two partial negative charges because it attracts electrons more on different sides. Okay, it has got polar bonds. So it has got polar bonds and it is also a polar molecule. So we can say it has got two partial negative charges like that. Oxygen has got two partial negative charges because of those interactions. Now, remember, water forms hydrogen bonds. So in ice, water is going to form four hydrogen bonds with other water molecules. But in liquid water, water is going to form an average of 3.5 hydrogen bonds. It is average, you can't count them because in liquid water, hydrogen bonds are constantly breaking and forming. That explains why water flows. Water moves on each other. Liquid water. Okay, at room temperature, water is a liquid. So water flows, it moves over each other. So it has an average of 3.5. But in ice, it has got four hydrogen bonds. Okay, actually, water is very dense at 4 degrees Celsius. So the bottom in the river, we're going to find that the water is at 4 degrees Celsius. And then on the top of the river, water is going to be at 0 degrees Celsius. And at 0 degrees Celsius, this is called ice. So ice is less dense than liquid water. That is why ice floats on water. And this is important, that is in cold seasons. The cold water goes on top, the hot water is down. That is why in cold seasons fish are going to be at the bottom of the sea. So water has got these are two single covalent polar bonds. Two single covalent polar bonds. Okay. The last molecule to understand, I just want to mention the bonds. The last molecule to understand is carbon dioxide, which is like this. So these two bonds we are able to see here. Oxygen is more electronegative than carbon. So this is going to be partially negative. This is going to be partially negative. So the carbon this side is going to be partially positive. This side is going to be partially positive. So carbon dioxide has got polar bonds. So you are going to show the dipole. The oxygen is more electronegative. So you show the dipole going towards oxygen like that. Also towards oxygen like that. Now, even if carbon dioxide has got polar bonds, it is not a polar molecule. Why? Like, see, you have got someone is pulling this direction, someone is pulling this direction. There will be no movement, okay, because these forces are the same, so there will be no movement. In other words, these two are going to cancel each other. So that's why carbon dioxide is a non-polar molecule, even if it has polar bonds. So carbon dioxide has got two double polar covalent bonds. Like this is double, this is double. For water's got it has got two single polar covalent bonds, but carbon dioxide has got two double polar covalent bonds. And when the atom is reacted in carbon dioxide, you can see that carbon is going to have 8 electrons in the outermost shell. Okay. In other words, the valence electrons of carbon when it has reacted are how many? There are 1, 2, 3, 4, 5, 6, 7, 8. Each bond has got 2 electrons. Now in water, if you look at water like this, in water, when oxygen is reacted in water, the oxygen is going to have only 4 valence electrons. 2, 4. So this is what I want you guys to understand for now. Water, of course, is another topic that we are going to look at. So this is going to be the end of this class for now.